continue on inequalities, and what we're going to do is talk about inequalities that involve absolute values. And there's a lot of application of this, because remember when I was first introducing absolute values, I talked about the difference between two numbers and the absolute value of that to mean the distance between two values. And so we have a lot of expressions that will involve linear expressions, the difference between two things, the absolute value, and so along the way I'll kind of repeat what the meaning of these things are, but for now let's just get into the algebra of it. You know, if we have the absolute value of in an equation like the absolute value of x equals 3, we actually have two solutions to this, right? We have x equals 3 or x equals negative 3. Now what happens with the absolute value is that if x is a negative number, the absolute value makes it a positive number, and so we have a positive number equals 3. And so I wrote it this way because if we're assuming that x is going to be less than 0, the absolute value will change its sign, and so we change the sign by making it negative. So if we have negative x equals 3, then x equals negative 3. And that's usually a step that we leave out, but that's where changing the sign outside of these absolute values comes from. So let me make it a little bit more complicated. So here we're having x plus 3, the absolute value of this equals 5. All right, so if x plus 3 is less than 0, then what happens is that what the absolute value does is it changes that that expression inside the x plus 3 to the additive inverse of that. You know, so instead of this being less than 0 now, it's going to be greater than 0 when we take negative x plus 3. Now, if x plus 3 is greater than 0, if it's positive, then the absolute value does nothing. Okay, then we can just get rid of that. And so we have these two expressions, and one of them, well, we make them both equal to 5. Now, the first thing that we do is solve the side that involves just all positives, and so when you take off the absolute value, you just solve this in the ordinary way of subtracting 3 from both sides. You find x is 2. So on this one, when we have this expression in parentheses as the additive inverse, or negative, we can multiply both sides by negative 1, and so we get x plus 3 equals negative 5, and so when we subtract 3 from both sides, we get x equals negative 8. So when we put negative 8 back in here, we get negative 8 plus 3 is going to be negative 5, and the absolute value of negative 5 is 5, so that works. Now what happens usually is that I'll write this often, this first line here, just to kind of explain what's really going on. The absolute value is changing the sign, so it's making one sign the opposite sign, and so when we multiply both sides by negative 1. Now, probably every algebra book that I've ever looked at starts you off at this line where it says when you remove the absolute value from here, what you do is you change the sign of the 5. And that's true, that's the way you do it, that's the way it works, but it doesn't come from the fact that the 5 changes its value. It's the function of the absolute value to change the sign. Okay, so when it's like this with inequality, usually there's not too much difficulty. So why don't you try one, figure this one out, see what you can get. Anybody get anything at this point? Anybody? Yes?
X equals 5 and x equals -7.
X equals, we have 5 plus 1 equals 6, and x equals -7, we have -7 plus 1 is -6, make that 6, so that's good. All right, so everybody managed this okay? Now notice that's an or there. X can't be two values. If you say x equals, I mean, probably in ordinary language you would say that x equals 5 and x equals -7 are the two solutions. Strictly speaking, it's or, because it's one value or the other, certainly not both. Okay, we'll try one that's a little bit more difficult. Okay, anybody get anything? Did you get something? No? Anybody? Yes.
I got a equals 2 sevens and or a equals -2.
Okay, so how did you do that then?
So I multiplied first of all 4 on both sides to cancel it out.
Okay, I want to talk about that, but that's what you did. You got 4 on both sides, so your first step looks like that.
Mm-hmm.
Okay.
And then I subtracted 6 from.
What happens to your absolute values? Okay, let me take this as an opportunity to talk about the way to do this. The first thing you need to do is when you have the absolute value isolated on one side, you need to set up two different equations. You really shouldn't be operating inside of the parentheses. Now, in this case, it probably would work out that if we multiplied both sides by 4 and then subtracted 6 from both sides, and we had the absolute value of 7a equals, what is that, 2 or something. But what you really should do is get into the habit of doing it like this. So the first thing with your isolated absolute value, you see there's nothing on the outside of this absolute value. Make two equations and then solve these the way you normally would. And so you got the right answer, okay, 2 sevenths and -2, but you got to be careful with it, because when you have negative signs inside the absolute value, they don't change sign one by one. It's the whole expression that gets changed. So here, this last red thing is just to check to make sure that I got the right answer, because it's not something you generally can do in your head. So we find that, yes, indeed, they both equal, whoops, this one should be just plain old 2. Okay. So now here's one where it's going to make a difference, okay? You can't just add 2 to both sides here. What you need to do is set this up as two different expressions. X equals, or 3x minus 2 equals -5, or x equals 3x minus 2 equals 5. Change the sign on the second 5. And then you solve these. And you get x equals 1 or x equals 7/3, and we can check that. So what happened here? It doesn't work. So if I take x equals -1 in the first case, I have 3 times -1 minus 2, so we have -3 minus 2 is -5, absolute value of 5 equals 5, but it doesn't equal the negative 5. What do you see about this that makes no solution here?
The absolute value can't be negative.
Right. So that's exactly what happens. We have an absolute value, and this thing is always 0 or more. And of course, if it equals negative 5, it can't be. So there's no solution. So numerically, you can work things out perfectly and not get the right answer. So with absolute values, it's really important that you check your work. Okay. Now the other, I guess the other point I was making was what happens when you have negative signs within the absolute values. And I don't think that's my next example. Okay, so let me show you what can go wrong with this if you operate outside the absolute values. Okay, so if we have 1 minus a equals 3, the thing that you don't want to do is, and many people will do this, is you say, okay, I'm going to take the absolute value of this, so this is 1 plus a. That's not the way this works, because it's going to take the absolute value of the whole expression, not the individual terms. So don't do something like this. Follow the procedure exactly, where you make your expression first where it's positive, and then second where it's negative, and then solve it. And so if we add a to both sides, we get 1 equals 3 plus a. Subtract 3 from both sides, so we get negative 2 equals a. Or we'd get 1 equals negative 3 plus a, and then we add 3 to both sides, and we get 4 equals a. So when we check this out, we get 1 minus a negative 2 equals 3, and this makes the absolute value of 3 equals 3. That one works. And then this one, if we put in 1 minus 4 equals 3, we get absolute value of negative 3 equals 3. So don't fall into this trap where you're taking individual terms in here and making the absolute value, because it simply won't work. Because what's happening is then you're only changing one of the values and not the other. So in order to be really fair about this, you would have to make this negative 1 plus a. And that's essentially what you get when we do this 1 minus a equals negative 3. So just don't even go there, okay? You have to deal with the absolute value expressions as a whole, and you deal with them by writing the two equations where you're changing the value on the other side of the equal sign. So here's your general strategy. You want to isolate the absolute value first. So if we have something that has other things on the left-hand side, like 2 times the absolute value of 4 minus 3x minus 6 equals negative 2, what you want to do is keep this thing intact. Don't distribute the 2 inside the absolute values. Don't do anything with this. Try and get everything on the right-hand side. So the first thing we're going to do is we'll add 6 to both sides, and then we'll divide both sides by 2. And so then we get down to this expression that we have the absolute value of 4 minus 3x equals 2. So at this point then we do what I had on the previous slides of making your two equations. The first one is assuming that what's inside doesn't get changed. The second one assumes that we are changing the sign. So we get these two answers. I know that's a lot of writing, but anyway, we have 4 minus 3x equals 2. Subtract 4 from both sides, and then divide by negative 3, and we get x equals 2/3. On this one, we're going to subtract 4 from both sides, and so we get negative 3x equals negative 6, x equals 2. So then we'll check, and the first one we'll do 2 times 4 minus 3 times 2/3 minus 6. So we'll simplify each of those. We get 2 times 4 minus 2 minus 6, and then we get 2 times the absolute value of 2 minus 6. 4 minus 6 equals negative 2. So that one works. And then we check the other one, plugging in the 2, And once we go all the way through every step, we find that we get -2 as well. So we have 2 times, well, we're just inserting the 2 into the expression here. Then we're simplifying. 3 times 2 is 6. And then we compute the inside of the absolute value. Take the absolute value of the -2 times 2 is 4. We have 4 minus 6 equals -2. So notice here, I have a -2 on the right side. And we found that before, when you have the absolute value of something equals a negative number, that doesn't work. But since we're doing other things to it, certainly this can work. It's when we get to this point where we've isolated the absolute value, what's on the other side of the equation, that's when it has to be 0 or more. Okay, and so here's the little caveat about don't do this. Don't say the absolute value of x minus 6 equals the absolute value of x plus 6 and taking the absolute value of that 6. Just don't go there. Because very often, if I'm just looking at this expression, x minus 6, if x equals 2, I don't get the same thing if I've already changed it to the absolute value of x plus 6. Okay? So just don't try and do any operations with the absolute value. Isolate it and then write 2 equations from it. Okay, so let's say now we have 2 absolute values in an expression in one equation. What we do with this is that we treat it like there's only one. And what it would seem like is that we would have to have 4 different cases, right? Where we would write in the first case, this is what we normally do, is we would say A equals B, and then we change the sign of the other expression. But if we looked at it from the other perspective, we say, okay, we're going to change the sign of the A equals B, or both A and B, we're changing the signs to make them equal. It turns out that if you look at the algebra between these two, the outer ones are the same thing, the inner ones are the same thing. So the only thing that we have to do is write it as though only one side of it has the absolute value. So in this case, we would write first if there's no change, so x plus 2 equals 3x minus 6. That's just taking off the absolute value signs. And then the second case is we're going to take the absolute value signs off and make the right side negative. And remember, just put parentheses around it, write a negative in front of it. You'll avoid making some sign mistakes if you do that. You know, let the problems, you know, work themselves one step at a time. And so when we have these 2 equations now, we can solve these. In the first case, we'll just add 6 to both sides, subtract x from both sides, and we get x equals 4. Make sure that when you're changing the sign that the -6 gets to be a +6, so we have -3x plus 6. And so we get 4x plus 2 equals 6, or 4x equals 4, x equals 1. And then check both sides. Okay, so we find that, yeah, 6 equals 6 and 3 equals 3, so we're good on both sides. Okay? So, time for you to try one of these. Oh, it's just another warning. Make sure you check. It's possible that one doesn't work and one works. Okay, so just because one works doesn't mean that everything is fine. You need to check both of them, because certainly we can come up with examples where one of them doesn't work. Okay, so for you to try this one. 2x plus 1, absolute value of that equals the absolute value of 1 minus 3x. I'll give you a little bit more time on here. Let's see how this works out. Okay, so there's the two equations. Now notice here, the negative goes on the outside of the expression. Don't try and do too many things with your negative signs to avoid some mistakes. And then we just simplify from here. And we do get 0 or 2. And I already did that in my head, so that all works. Okay, any questions on these? Good on these? Okay, so always remember that you're at least trying to get 2 different answers with absolute values. It may be that you only get 1, but or you may get none. Anyway, you should always try. Okay, so here's another one for you. All right, how about this? Okay, so we make our two equations. Now, if we look at the first side, we get, if we subtract 2x from both sides, there's no value of x that makes that side true. The second one, we can get to -4. So let's take -4 and see, does -4 work in here? Okay, so we'll say 2 times -4 plus 7 equals 2 times -4 plus 9. And so we have -1, absolute value of that equals 1. So here's only one solution, and that's x equals -4. So you need to look for 2, but it's possible that you only get 1. Okay, so now what I want to do is talk about absolute values with inequalities. And so these are going to have some characteristics of the inequalities that we've been dealing with before. But I want you to think of this expression again as a distance. Okay, so the absolute value of a minus b is the distance between the values of a and b. Okay, it's like when, like I described earlier, when you measure something, you don't care if you measure from left to right or right to left, you still get a positive value. And that's the same thing here. If we're looking at the distance between two things, it's a positive value. It's not ever negative. All right. So if we look at these expressions like this, where we have x minus 6 equals 3, what we get is x equals 9 or x equals 3. If we put that on a number line, you can see what happens here. We'll have this expression, the absolute value of x minus 6, is you're saying what number, the distance from that number to 6 equals 3. Well, there's two numbers then. One of them is 3, because 3 is 3 units away from 6, and 9 is 3 units away from 6. And so that's kind of the physical meaning of what this is. Okay, so we're trying to find a number. Its distance from 6 is 3. Okay, so if we look now at inequalities, we can think of x minus 6 is greater than 3 is that the distance from x to 6 is more than 3. And so the algebra works out to be about the same, where 3 and 9 are the correct kind of endpoint numbers. But if we're looking at what is greater than 3, we'd have to say, well, 0 is more than 3 units away from 6, and 10 is more than 3 units away from 6. And so we have now not only a single value, but like we had with inequalities before, we have an interval that we're working with, or in this case, 2 intervals. Okay, so how do we work this out? So remember, the absolute value changes the sign of this expression. So if x minus 6 is less than 0, we get negative x minus 6, which will make it greater than 0. Now, if we do one iteration on here, we're going to multiply both sides by -1, and so this becomes a -3. But notice what happens with this inequality sign. It changes to the other direction. And that's key here. So a lot of people remember the rule that you need to make the one side negative and change the inequality sign. The reason why you have to do that is because the absolute value is really changing the value of the left side. And then when we multiply both sides by -1, that's the rule that changes the direction of the absolute value. And that's why that changes like that. Okay, so let's solve this then. If we add 6 to both sides, in both cases we'll have x is greater than 9 or x is less than 3. And so the way we can check this is we'll take a number that's somewhere in that interval and see if it's true. So in this case, I'm going to say x is 10. So if x is 10, based on this, we should get a true statement. So if we say 10 minus 6 is 4, absolute value of 4 is 4, and yeah, that's greater than 3. Or if we take 2, which is on this interval, that's part of the solution, we're going to say 2 minus 6 is -4, absolute value of 4, -4 is 4, so we get 4 is greater than 3, that's true as well. So the reason why I suggest you do this is because if we have the other case where it's less than, none of these values are going to work, even though we might correctly arrive at the 3 and 9 numbers, which are part of the solution. But is it supposed to be greater than or less than? And so this, this method helps us decide, did we get the inequality right as well? Okay, so then let's look at the other case, where we have x minus 6 is less than 3. Okay, so the distance from x to 6 is less than 3. Put this on a number line again, and so we still come up with those same key numbers of 3 and 9, but now we're looking at values that are within 3. So 5 is only 1 unit away from 6, and yes, that would be less than 3. So 5 minus 6 is -1. Absolute value of that is 1, which is less than 3. Now the thing about this is that when we split this up into two different equations, it's no longer or, it's and. Okay, so think of it this way. If I'm going to say, let's say the width of this room is 30. All right, so from me to the wall is 15 feet, and me to the door is 15 feet. If I'm going to say, I'm looking for all the people who are further than 15 feet away from me. You can be on that side of the wall, somewhere out there, or you can be on that side of the door, somewhere out there. Okay, so either of them apply. So when you're looking at a distance further than something, you're looking at or, because you can be one condition or the other. But if I want to say, what's the distance from, or who are all the people that are less than 15 feet away from me, there's two conditions that have to apply. One of them is that they're on this side of the wall, but they're also on this side of the wall, right? It's not sufficient that they're on this side of the wall, because then somebody in the hallway is still further than what I'm looking for, but it meets that condition. So it's not, you don't have or, you have and, because both conditions have to apply. So when you're looking at something that you want it to be within a certain value, there's both an upper and a lower bound there. When you're looking at something that's outside of a certain value, then you're looking for a number that's either one way or the other. Either condition applies because there's no overlap. But we're looking for the overlap region between the two. Now, just like I did before, I'm changing the sign of this 3, and I'm also changing the inequality sign to be a greater than sign now. So then when I work this out, I get x is less than 9 and x is greater than 3. So if you think about what this is really saying, okay, you can be greater than 3 and less than 9, so you can put this in one expression, 3 is less than x is less than 9. So instead of an or condition, now we have an and condition, and that's actually, you know, reflected in this kind of interval. So the way you check this is you choose a value that's within that interval. So like I did earlier with 5, well, 5 is between 3 and 9, and if I put a 5 in my original equation, I get a true statement. Okay, so I know that my the direction of my inequalities is correct in this. If I got them wrong, if I forgot to change them around, or if I changed it around in the wrong way, then I would have a number that's outside of this range, and we would get the wrong answer. Okay, everybody up with me on this? So it's time for you to do a couple now. Okay, try this one. And first decide, before we start, is this an and or an or? What do you think? I'm looking for an answer. Is it or and?
Or,
It's or. So why would you say that?
because it has the greater than or equal to sign,
Mhm.
not just greater than or less than.
Less than or equal to.
This one.
Yeah, I know what you were.
Okay, yeah, sorry, I got it.
Yeah, so you're looking for a distance that's greater than something, so it can be outside of either boundary, so it's an or. Okay? If it was less than, you want it within a certain value, and so it would be and. So you're right, it's or. Okay. How did we do? Anybody get anything here? Okay, so we do this by, we've already established it's an or. We change the direction of the inequality on the right side and make it negative 11. And so we just solve by first adding 3 and then dividing by 7. And so we get x is greater than 2 or x is less than or equal to negative 8/7. And so when you plug this in, the first one computes pretty readily. We get 11 is greater than or equal to 11. And the second one It's not so bad. 8/7 times 7 is 8, so we have a negative 8 minus 3 is negative 11, which after you take the absolute value, you get 11. Okay, so a different one now. So this is a little different. Okay, how did you do on this one here? All right, not sure? Where was the difficulty? Okay, so we have the same strategy. We want to isolate the absolute value, and then we do it in the normal way. So the first thing we're going to do is multiply both sides by 4. So 4 times 30 is 120. And then, since we have a less than, so we look at this equation here, we have a less than 120. So the difference between y and 16, or the distance from y to 16, has to be less than 120. So we're talking about an and here. And so our two equations then turn out like this. And then we add 16 to both sides. And so we get 100, y has to be between negative 104 and 136. Okay, so the first thing that we can do here is notice that this goes from negative to a positive, and we're in between there. So the real quick and dirty test to see if we're right is 0 is in that range. So pop a 0 in here and see what we get. So we get absolute value of negative 16 is 16 divided by 4 is 4, which is less than 30. So on a real quick check, you know when you have 0 as part of your solution set, check that, because that computes faster than any other number. So there's a kind of a little pointer there. And so if we check this, so we get the boundaries of this thing. Notice that I'm computing it to be exactly equal to and not greater than. So here I'm checking the fact that is my 136 and my negative 104 the right boundaries. If it was, then this equality should hold. And then trying 0 says that yes, it is on the inside of these boundaries. I guess this 104 and 136. Yes?
Could you just reduce the fraction in the beginning problem, 16 over 4? Or
No, if it's positive, you can bring it in, but you're going to make some difficulty for yourself, because what you get is if you have y minus 16 over 4, the proper way to reduce that would be 1/4 y minus 4. Okay? So you can't just, can never do that, in fact. When you're like this, you still have to do that, where it's each term, not just the second term. Okay, so I have 4 problems up here that have some something special about each one of them. So if you do these, and perhaps, I don't know, work with your neighbor or something like that, I'd like 4 of you to come up and write the solutions to these once you have them. So I'll let you work on it a little while. I'll come around and see who's making progress, and then I'll ask you to write these on the board, the solutions.